if you want to basically check on a certain figure that where that figure is in equilibrium or not equilibrium, so basically you guys need to understand is that an object will be in equilibrium if there is a single point where all the forces acting on it will meet. Now, what do I mean by this? So, what I mean by this is that let's suppose if there is a shape, it looks like this. There are a couple of forces acting, like this one, and this one. So if I draw their line of actions, line of action means that in the line like this, and all these forces basically come meet at a single point, so which means that this body is in equilibrium. Do you understand? So what you guys need to do is, if they ask you a question like this, you just need to draw the line of actions. They must come at a single point. Now let me show you another sort of drawing. Suppose they have a wall, and then there is an object. It is being supported by two supports A and support B, and at A they have connected with the wire like this, right? So now they have shown a couple of forces, like here there is tension T, its weight is somewhere here, and then there is a reaction from, oh my god, there is a reaction from support B, R, the reaction force. So if they say, okay, basically if it's in equilibrium or not, you're going to extend the forces line of actions, and then if they meet at one point, which is this point, now it's meeting, so this is why it is in equilibrium, and this point is generally called as the point of equilibrium. Is it clear? Any questions? All right. So, Aman Aisha Javeria, please draw this. Okay.
Okay.
All right. That's pretty good. Now, should I go forward now, everyone?
Yes, sir.
Javeria, when will you come to the class on time? Please tell me. The day I want to, I want to
I
write it
mostly
down.
come on time, but there was some problem in minutes, so today I couldn't give them this.
Okay. Now let's look at moment. So most of the things in this chapter you already know. So moment is basically the turning effect of a force, but that's not how we define it in this. How we define it is that moment is the force applied at a perpendicular, this is a key word, so I'm going to star it. Force applied at a perpendicular distance from pivot, causing a turning effect. So this is the definition that you need to write. Force applied at a perpendicular distance from pivot. So moment is written as m, and that's force times the perpendicular distance. The SI units of moment is Newton meter. And remember, because it has a specific direction, so it is a vector quantity. Also, Javeria, where is your work? Did you do the worksheet? Because I don't have it.
Yes. Yes, sir, I did it. I submitted after the class.
Okay, please submit it. I'm going to check it tomorrow. Okay, so the clockwise moments are like this, and anti-clockwise moments, like anti-clockwise directions, like this. All right. Any questions you guys have? Please let me know. Okay, now. So, suppose, to an example, and it says a force is applied at 60 degrees from the end of a plank calculate the moment. So they have actually shown the plank as well. Looks like this. There is a pivot and a force like this is shown, which is 40 newtons, and it is basically 60 degrees from here. Okay, this distance they have given as pivot to the force, that is 12 meters, and of course this is the pivot. All right, now so there are two ways of doing this. One that I prefer, one that I don't, but sometimes it's also useful. So we're going to look at it. Now, according to the definition, basically, you need to find the perpendicular force to the distance, right? Because the definition says that force is applied at perpendicular distance. Now, Right now it is not perpendicular, it is at 60 degrees. So what we can do is we can make two components, one vertical up and one like this. Okay, now this will be 40 cos of 60 and this will be 40 sine of 60. Do you guys agree?
Yes, sir.
Because this 40 sine 60 is 90 degrees to it, so we can simply then use moment equals to force times the perpendicular distance, and it is going to give us 416 Newton meter as the answer, right? So I prefer this one because it's easier, faster. On other hand, what you can do is you can basically, so I'm going to write method 2. And in method 2, remember, you can extend this like the line of action. And then you can find, because this is now 90 degrees from the line of action. So if I could find this length, x, I can multiply it by 40, right? So top one is 12, this angle is 60, because this is the corresponding angle. So first of all, what I would like to do is I want to find x. So I want to find basically the opposite and the hypotenuse. So the best method is to use the sine rule. So sine 60 degrees over x, and the angle opposite is sine 90 over 12. So from this side will be 10.4 meters, and from that we can use moment is force times distance, and we can multiply 40 and its perpendicular distance, which is 10.4. So it is going to give us the same answer. Is it clear?
Yes, sir.
So it really depends what you like, whether you want to make the direction, the distance perpendicular, or you want to find the perpendicular force. It's up to you. It's just that the method 1 is much, faster. So generally I would prefer that. Now, so there could be only 3 conditions, okay? So the 3 conditions are, let's suppose you got plank like this, plank like this, and a plank like this. So suppose one force is acting upwards like this, force F, this is distance T, then the force could be at a certain angle, same force but a certain angle, F, and distance T, and then a force which is parallel like this and the distance T. Okay, now think about it. In the first one, you guys need to understand this, that whenever it is going to be 90 degrees, so moment is going to be force times distance, and this is going to be the largest possible one, because all the force is helping the plank to turn this way. Is it clear? In the next one, we would have to make vectors, and if I make the perpendicular vector, this will be 4 sine theta. So the moment will be F sine theta times T. In the next one, basically because the force and distance are parallel, so the moment would be just zero. This is no moment at all. The reason is that that force is pulling the plank to the right, but it's not actually trying to turn it clockwise or anti-clockwise. Do you guys understand this?
Yes, sir.
Now there has to be some mathematical explanation as well. Like this is 90 degrees, we know that could be any angle, and this is 0 degrees because it's 0 from here. So if you put, generally the general formula, which you don't really need to remember, apply. The general formula for moment is that moment is equal to force times distance times sine of theta. Now, if you take out your calculator and you put sine of 90, what do you get? Can you please tell me that? Yes. Do it, hurry up.
1.
Sine of 90 is 1. So basically that is why in this figure we just write force times distance because sine 90 gives 1. Do you understand? Now, if that angle was 60, so we do sine of 60, what do you get? Can you tell me?
Zero 0.866.
So 87, right? So it's basically less than 1, so it will give you a smaller moment. If that angle was 45, what would you get?
0.71.
0.571, okay, right. 0.71, are you sure?
It's like 0.707, so
Okay.
rounded it.
Okay. एक second. Okay. And then if I say sine of 0, because that was 0, what do you get?
Zero.
0. So that is the reason there is no moment there. Do you guys understand this? Okay. So what we basically learn is that here, what the angle plays role is that the maximum moment is produced when the force and the distance are perpendicular. And if there is any other angle other than 90, it is going to give you a smaller moment. Do you guys understand this? Okay, now the other thing that really affects moment is the distance. So let me just show you with an example. Everyone has a door in their house, right? So have you ever considered that the door that you have, why is the hinges of the door are here, but the knob is here, right? Have you considered that maybe, just maybe, if they wanted to, they could have, put the hinge. Wait a second, let me move it to the right location. Okay. They could have moved the hinge much closer move the knob much closer to the hinge. So this is the distance, and in this one, this is the distance, right? Why haven't they done that? Any idea? You could apply perpendicular force to both of them. The reason is that if suppose this was like, this is like 2 meters and this is just 0.5 meters, and the force you apply is like 100 newtons and here 100 newtons. So the moment this would provide is 100 times 2, that is 200 newton meter. So it is more likely to turn, and here the moment would be 100 times 0.5, which is just 50 newton meter, so it is less likely to turn. So the other thing is that you guys need to remember that the larger the distance is, so the larger the distance is from the pivot, so larger the moment produced. Is it clear? All right. Now, have you seen the nuts on a car tire? All right, when the meeting ends, okay, you guys need to rejoin the same link. Okay. So on the tire there are nuts, right? On the wheels basically, not the tires. So the nuts basically looks like, okay, I'll make a simple one like this. So if I say, okay, try to open this with your hands, so you'll probably put your fingers around them and apply a force like this, and the distance from, the screw is T. So basically you will have to apply a lot of force to turn it. Don't you guys think so? But if you add a spanner to it, so what a spanner would do it, that you're applying the same amount of force Okay. So basically, you're applying the same amount of force, but now the distance between the center to this has increased. So that would cause basically you to do less effort. Is it clear? Yes, Aman. Aman, you can hear me, right?
Yeah, sir. Can you repeat that?
Yes. What I'm saying is, can you open a car wheel nut using your hands?
No.
Because where you apply the force, the distance is very, very small. So you have to do a lot of effort, right?
Yeah.
But if you use a spanner, you have to do less effort because the distance is larger. The reason is that suppose in this one, the distance was 0.2 meters, and in this one, the distance was like 5 meters. So I say, okay, the moment required to turn it is 600 Newton meter, let's suppose, right? So in the first diagram, if I try to find the force, so moment is force times the perpendicular distance. I need 600 Newton meter to turn it. I need to calculate the force. The distance is 0.2. So basically you need to apply about, say, 3000 Newton of force. That's why your hand would hurt it or not turn. Is it clear? On the same nut, if I increase the distance by using the spanner, the moment required to turn it 600, I need to calculate the force, but the distance was 5. So 600 divided by 5, I just need to apply 120 Newton of force, which is much less effort. Is it clear?
Yeah, sir.
So the third thing I want to tell you is that the greater, all right, for equal moment, the greater the distance is, less force, less perpendicular force is required. Okay. So that means that force is inversely proportional to the perpendicular distance in this case. Alright, Aman, Javeri, Aisha, any questions you guys have, please let me know. Okay. I think everything is clear then. So now we just need to learn how to find moments, right? Then I'll tell you how to, when you're looking at a figure, how to do that. Okay, now let's look at when we need to find the resultant moment. Now let's try to do this. Okay. Okay, so there's an L-shaped figure. There is a pivot right here. It's like this is the line of action of pivot. So there is a force right here. That's 8 newtons. There's a force right here, which is 6 newtons. There is a force here which is 10 newtons. There is a force on this side which is 4 newtons, and there is a force this way that is 5 newtons. And then they have also given you the distances. So from the pivot to this one, this is 20. From pivot to this one, this is 40. From the pivot to this one, that is 15. And from the pivot to these two, it is 30. Is it clear, everybody? Now,
Yes, sir.
so they say find the resultant moment. So this is the question now. So what you guys need to remember is, okay, I need to Step 1, find the direction of moments. So this is the first thing you want to do. Just look at the pivot and forget about all other forces when you're looking at just one force. If you look at it, you see it is trying to turn it in this direction, and that is basically anti-clockwise. Do you guys understand this? Okay. Javiria, can you tell me what is 6 Newton doing? Where is it turning the pivot? Have any idea?
Sir, it's perpendicular to 30 meters.
From the pivot, 6 Newtons, 30 meters. Are you sure?
No, sir. There is no distance. It's 0.
Yes. This will be providing 0 moment because it is parallel to the pivot. It has no perpendicular distance. Do you guys understand this? So I'm moving at all. Now, Aisha, can you tell me about 10? Where is it turning?
10.
Yeah, this one.
Clockwise, downwards.
Yes, so it is trying to turn it clockwise because now it has a perpendicular distance from the pivot, which is 15 as clockwise. Okay, Aman, what about 5? Where is it? 5. What is 5 trying to do?
So I'm not sure.
Okay, it does have a perpendicular distance, that is 30, and if it's pulling it up, it will try to turn Aman like this, anti-clockwise. Do you understand?
Yeah, sir.
What about 4 then? Imagine only 4. Forget about everything else. What would 4 do?
It will try to put it right side.
Yeah, it will also turn it anti-clockwise. Very good.
Yeah.
Alright, like this. Okay. Now that you have done step 1, you have identified all the directions. Now you go to step 2. In step 2, you find the sum of clockwise and anti-clockwise moments. Now we would write clockwise here, anti-clockwise here. So the only clockwise force was unfortunately 10. So we're going to do 10, and the perpendicular distance of 10 is 15 because it's right here. So I'm going to write 15. And then there are only anti-clockwise. So for 8, it is going to be 20. That's perpendicular right here. Okay. And the next one is 5. So 5 times 30. So that's perpendicular. And can you guys tell me about 4? What is the perpendicular distance of 4?
Forty.
40. Very good. So it is basically this force because that's perpendicular. So it's 40. Very good. Now there's nothing left because the 6 Newton had no moment at all. When you add it, it's going to be 470 Newton meter, and when you add this, it is going to be just 150. Now the resultant, you can assign the signs, it's fine, or you can just simply subtract them. So it will be 320 Newton meter anti-clockwise. Understood? So what I want you guys to understand is that you always need to see what directions are there, right? Once you identify the directions, then you just need to look at the perpendicular distances, add clockwise together, add anti-clockwise together, and then you can subtract them. You will be able to find the distance, right? Any questions now?